Welcome back, everybody. Welcome back to Tommy for round 2 of our individual training session. We'll be following on from our last one, which was identify hazards and implement controls with safety in brakes. We also have Mr. Malcolm Moraes in as the Cert 4 training and assessor to do his third-party observation. If you remember from last time, Tommy, we were doing hazards, implementing control measures with light vehicle braking systems. Today, we are going to be looking at tools and equipment for servicing light vehicle braking systems. So, tools and equipment. We have measuring tools, vernier calipers. Vernier calipers can measure the outside diameter or thickness. They can measure inside diameter. They can measure length, and they can also measure depth. So we've got our little depth gauge there. So we can measure basically 4 things with one tool: outside diameter, inside diameter, the length of something. Depending on what size verniers we've got, they do make bigger ones, and we can measure the depth of something with that. We also have micrometer. This is an outside micrometer for measuring outside, the outside measurement. This is a far more precision instrument than verniers. And we always got to make sure that we zero the micrometer before we take a reading, because that will give us an accurate reading. If it's not zeroed, it could be over, it could be under, might not be the specifications according to the manufacturer. So we have vernier calipers, we have micrometers. We also have what we call a dial gauge. So a dial gauge is what we use for when we're checking brake rotor run out. When brake rotors get hot from braking, constant braking, if our brake fluid has lost its boiling point and is overheating and those brakes are getting hot, we can warp the discs. When brake discs are warped, when you put your foot on the brake to brake, you might feel the steering wheel shake, or you might feel the car shuddering when you're braking, only when you're braking. That means we have brake shudder, and that our rotors are probably have excessive run out, or they're warped severely. So this is the tool we use to actually measure that run out and compare it against the manufacturer's specifications. So we're going to be talking about these tools today. We will be using the verniers, and we're going to measure a rotor, and we will use the micrometer, and we'll do the same measurement to see if we get 2 different sizes. Okay? Any questions so far, Tommy?
No.
No. It's all good. So, moving along. Basic hand tools. So, our basic hand tools are going to make up basically a generic toolbox, really. All you need is a generic toolbox, socket set, ratchets, maybe a breaker bar, because sometimes bolts are really tight. So we might need a breaker bar, deep reach. Impact sockets are probably the best sockets to use. Screwdrivers, you might need flathead or Phillips head screwdrivers, different sizes. You might have to undo backing plates or drums. Sometimes they've got screws holding them on brake drums. So you might need selection of screwdrivers. Specialised pliers, In brake drum systems, they have a lot of springs, and you can get special spring pliers for them, so they're more specialised. We'll talk about that in our another unit, because we have another unit where we're actually going to be using the tools and doing that. Other tools we would use is a torque wrench. So torque wrench is basically essential for precise tightening of all our hardware to manufacturer specifications. So what could happen if we didn't actually tension a bolt up on the front caliper correctly? What could that cause?
For it to be loose or
It can
unstable.
come loose, yeah. We could, it could fall out, cause a catastrophe, fatality, or if we've over tightened it because we haven't used the correct torque. Every nut and bolt on a car has a torque specification depending on its size, type of thread, what it's screwed into, what it's clamping. Every nut and bolt has a torque spec. So we might over tighten it if we don't use a torque wrench. We could over tighten that, stretch the threads. We could strip the threads, and then we're in all sorts of pain and bother then. That's when we start getting into, oh my God, what have I done? How am I going to fix this? Not how I'm going to hide it, how am I going to fix it? Because we don't hide anything, we're always up front, and we tell our supervisor whenever we have an issue. We make sure we tell someone in charge so they're aware of it. So moving on to our next slide. So we've got a basic understanding of how brake calipers work and how the braking system works. We'll just watch this little video on YouTube, how the hydraulic brake calipers work in a car. So it gives you a bit of insight as to what's actually happening whilst these are going on.
Welcome to Bendix Brakes. Today we'll look at how a modern disc brake system works. We'll start by looking at the brake components involved in stopping a vehicle and how they work together.
Everyone hear that?
Yep.
Starting with one of the main components in the braking system, we look at the disc rotor, which the brake pads squeeze against. This will create friction that decelerates the rotation of the wheel and the vehicle. The caliper is activated by the brake fluid hydraulic pressure produced from the vehicle's brake pedal and master cylinder. In this assembly, the brake pads are squeezed up against the disc rotor surface to create friction. A caliper is made up of multiple parts, all critical in the effective operation of the brake system. These parts include the caliper and mounting bracket, slide pins, locking bolts, dust boots, brake mounting clips, brake pads and shims, the brake piston with a dust boot and seal. The caliper is fed brake fluid through a banjo fitting, which drives the piston forward towards the inside brake pad when the brake pedal is pushed. This causes the caliper to move along the slide pins, which then pulls the outside brake pad up against the brake disc rotor. Now that we understand the parts, let's see how the braking system works. Hydraulic brake pressure will cause the caliper to move along the slide pins, pulling the outer brake pad against the opposite side of the disc rotor, causing friction and decelerating the brake and the vehicle. When the brake pedal is pressed, the caliper will receive high pressure brake fluid from the master cylinder, which will push the piston into the inside brake pad and onto the disc rotor surface. Looking at the braking process from another angle, we can see the brake fluid pushing the piston, which in turn pushes the inner brake pad against the inside of the disc rotor. Once this has happened, the fluid will now push the caliper along the slides and the outer brake pad will be pulled towards the opposite side of the disc rotor. Thanks for tuning in. We hope you've learned the fundamentals of how Bendix brake pads work with a modern braking system. And always remember to fit Bendix brakes.
So that was quite informative, wasn't it? It's probably one of the best videos I've actually watched on braking systems. It gives you an understanding of how they work and what's going on. So moving along to our next slide, we've actually got some specialised brake tools. So this tool up here is basically designed for brake bleeding. That's a little vacuum pump. We've got a little reservoir there. So when we're changing the brake fluid, we want to change all that brake fluid, not just what's in the master cylinder. We want to flush all the brake fluid out of all the lines, all the brake lines, all the way back to the rear of the brake calipers. So when we're flushing brake fluid out, we want to start at the wheel that's furthest away from the master cylinder. So predominantly, master cylinders, brake master cylinders, are fitted to the driver's side of the car, because that's where the driver sits, that's where the brake pedal is, that's where the vacuum booster is, the brake booster, and that's where our master cylinder is. So the wheel furthest away from the driver's side front would be, which wheel do you think it would be?
Back seat of the driver.
Left hand rear. Yep. So left hand rear. So driver sits in the right hand front. The furthest wheel away is the left hand rear. So we would start taking the fluid out from the left hand rear wheel first. So we would make sure that our master cylinder is topped up. We would start extracting fluid out, and we would also make sure that someone is topping up the master cylinder with fresh fluid. Once that new fluid starts coming through that line, we could close off the air fitting, the bleeder, and we'd move on to the right hand rear. That's the second furthest away. Then we would do the same process. Keep sucking that out with the vacuum bleeder. They do make lots of different types of brake fluid extraction stuff. Some are compressed air, some are force fed. This one is actually a vacuum pump. So start off with the left rear, then we go to the right hand rear. So the next one after the right hand rear, furthest away from the master cylinder, would be left hand front. Then we go to the left hand front and start extracting the fluid out through the lines, through the caliper and into our container. Then we finish off with the right hand front. Then we contain that fluid in our liquid hydrocarbon bin because it's toxic. We can't just tip it down the drain, we can't mix it with water. Water will basically diffuse brake fluid, but it's still toxic. So we don't tip anything down the drain. We make sure that we're disposing of it as per Environmental Regulation Act. That other section over there, that is a picture of a brake caliper with a caliper piston tool. So as we've seen on that video, as the hydraulic pressure forces the brake pads onto the rotor, every time it does that, those brake pads are wearing. It's taking a limit off, a section of brake pad off. Hydraulic pressure remains equal in all states of area. So every time that wears down, the hydraulic fluid pressure is keeping it close to the rotor. So when those brake pads wear right down, we saw the piston coming out. When you need to replace your brake pads because they're worn out, you need to reset the piston back into the caliper. So I have a caliper right here. That I will show you. So this is our brake caliper. This is a dual piston brake caliper. You can get single ones. This is a dual piston floating caliper. This is called a floating caliper because it slides. Like the video, the inner pad gets forced out first, which puts pressure on the rotor, which then allows this side to get pulled in towards the rotor. So we've got one pushing and this one's pulling in towards it. So as they wear down, these little pistons here come out and they stay out and they keep the brake pad up against the rotor. So when your brake pads need replacing, when they're less than 3 mil, you have to push that piston back in. So we use the caliper tool, which goes in there, and we screw that in and we force the piston back. You can also use a C clamp, G clamp, F clamp if you have to. You could use 2 pry bars. However, they make proper tools, and in some instances, some motor vehicles, you actually require special caliper winding tools, because some calipers have threads and they're actually wound back in, not forced back in. So you just got to make sure you refer to your workshop manual, the correct procedure for doing that. So we'll move on. What else is on there? Brake bleeding equipment. So brake bleeding, that's basically once you're using that to remove the brake fluid, you're actually bleeding it at the same time. You're killing 2 birds with 1 stone. Brake line wrenches, otherwise known as tube spanners. Do you know what they are? Okay, so a tube spanner, I don't have one here, is basically a spanner designed for pipes, for undoing brake lines. So a ring spanner, you can't fit that over a pipe. It has no gap in it. So tube spanners, pipe spanners, all have a little gap where you can fit it over the pipe, put it onto your line and undo it. If you don't use one of them, you would have to use an open-end spanner. Are you aware of any problems with using open-ender?
No.
Okay, so open-ender spanners, you can round off the brake tube or the brake line. You will round that nut off, and then we're in all sorts of dramas. We're like, the sky is falling, because we've rounded it off. Because that does happen, because people don't use the right tools. So, as I mentioned, brake bleeding equipment, you can get manual pressure bleeders, you can get vacuum pump. That one is a vacuum pump. You can get electronic bleeding systems, because we need to remove the air out of the system. So a hydraulic system won't work properly if it's got air in it. It causes the pedal to be spongy, not firm like it should be. So once air is in a hydraulic system, we've got cavitation, we've got air in the hydraulics, oil, it's not going to function properly. It's going to compress, because you can't compress a liquid unless it's got air in it. So, is there anything you want me to elaborate on? Caliper tool used for pushing pistons back.
Is that what it's called, caliper?
Brake caliper, wind back tool, push back tool.
Okay.
But you can use just a normal G clamp. You can just put it over there, tighten it up, and it'll just push it back. I've actually pushed some brake caliper pistons back with my hands.
Yeah, how did you do that?
I just pushed it back. I opened up the bleed nipple to allow the fluid to come out, and I just pushed it in by hand. Some will get really hard to push back, but they could be partially seized, but we'll talk about that later on in this presentation, because we do talk about problems. So, moving along. Equipment for inspection and serviceability. Measurement tools. Micrometers for precise rotor thickness, and we all know that's a micrometer. We've got dial indicators for detecting lateral runout. Dial indicator, that's our dial indicator. This one's magnetic, so it's got a magnetic base. So when you've got your wheel off and your rotor off, you would attach that to a metal part of your vehicle, and you would align your dial gauge onto your rotor, and you would turn your rotor slowly and watch the needle go up and down, and then compare your reading to manufacturer's specs to see if we are within specs or out of specs. If we were out of specification with rotor runout, how do you think we could fix that?
Like, putting the indicator on and then.
If our rotor had excessive runout,
Yeah.
that disc rotor, how do you think they would we can repair that without replacing it?
Using the dial indicator, but I'm unsure of.
How to repair it?
Yeah.
Well, we would go see our machinist, and we would say, any chance you can whack this on the lathe and machine these surfaces for us so that we've got no run out.
Oh yeah.
So that would go on a lathe or a specific brake lathe, because they do make brake lathes that cut both surfaces together, inner and outer. If we were to go out in the workshop out here, throw it on our lathe, we could only probably cut one surface at a time. We would have to cut the front face, take it off, turn it round, and then cut the other face, which is not a big deal. However, brake lathes will machine that whole surface, both sides, at one time. So, we've got dial indicators, micrometers. It doesn't mention vernier calipers up there, does it? No. Vernier calipers are the quickest, easiest way to measure a rotor when it's on the car. Visual inspection tools. We're going to need lighting, aren't we? We're going to want to have lots of natural light. If we're in a dark workshop and we're trying to read verniers or read the dial on the dial indicator, we're going to want to see it, and we're going to want to see it clearly. So we're going to make sure we've got adequate lighting. Make sure we've got some lead lights, workshop lights, beaming down on what we're looking at. Brake pad wear gauges for quick thickness assessment. They do make a brake pad wear gauge. It's different colours, it's colour coded, so it could be green, yellow or red. So I don't have one of them because I prefer to use vernier calipers. However, in some workshops they just have a quick caliper tool, it's colour coded, it sort of looks like a brake pad, and they just put it up beside it, and if it's in the red it means danger, danger. You know, red means danger, red means stop. Stop what you're doing and replace my brake pads, please. Yellow is still in the OK range, green, good to go. However, I prefer to use verniers. So I would get my verniers, I would open them up, I would make sure it's zeroed. Is that zero to you?
Yeah.
Of course it is, isn't it? 3 zeros make a 0. And I would open that up like that, and I would put that down to there, and I would take a reading and 4.61 mil.
Yeah.
What's our minimum thickness state for brake pads?
Is it 0?
3.
Okay.
If it was 0, then we're running on metal. Minimum thickness for brake pads, 3 mil. So when we go down there, check the thickness of that. We're at 4.61. So we're only, what, 1.6 mil off from being minimum thickness. If we went to all the trouble of taking these brake pads out and we're at 4.6, are we going to put it all back and tell the customer, come back when your brake pads are 1.6 mil more worn down? No, we're not, are we? We're going to ring the customer and say, hey, look, your brake pads aren't at minimum thickness yet, but they're very close to it. Would you like us to replace it while we've got them out? And they might say, well, yeah, of course, please do that. Otherwise, I have to come back and you're going to charge me to do the job again. If you've already got it apart, then please change it. So, minimum thickness, 3 mil.
What's the max?
Well, the maximum thickness is whatever will come out when they're new. Oh, look, it just so happens I have a brand new one right here. So, let's have a look, see what this one here is. So we are at 8
Yeah.
mil. So technically 4 mil, it's only half more really, isn't it? Not really, if the minimum thickness is 3 and a new one's 8, that means you've only got 5 mil of material. Isn't that correct? If my mathematical brain serves me correctly, we've only got 5 mil of material that we can use before it's at minimum thickness. Some brake pad manufacturers have actually made little wear indicators that are attached to the brake pad, so that when it gets to that 3 mil, a little metal tag starts rubbing on your brake rotor and starts causing a high-pitched squeal. Okay, so that's the brake warning gauge saying, hey, all this squealing I'm doing is saying, please change my brake pads. And they also have electronic ones, a little sensor in there, it brings up a light on the dash and tells you need your brake pads changed. Anyway, moving along. Safety gear and workplace procedures. Obviously PPE, safety glasses to protect eyes from debris, fluids, chemical resistant gloves, prevent skin contact, respirator, mask when working with older brake components may contain asbestos. May contain asbestos. We can just assume every car has asbestos in it, because how do we know if it may or may not? We don't. They're not going to tell us. Steel cap boots, adequate lighting, there we go, proper ventilation. Can you see that picture?
Yeah.
What's the safety aspect with that young person you can see?
Wearing safety glasses.
She's got safety glasses
And gloves.
and gloves. Do you think she should have a mask on?
If required.
If required. Well, she's not directly working with brake dust, but yeah, I'd probably have one on.
Or do you wear a respirator?
Yeah, you could wear a respirator. Establishing serviceability. So we've got to make sure we check for obvious damage, leaks, excessive wear before disassembly. A bit like our last unit we just done. Inspect for cracked components, damaged seals, unusual wear patterns, measurement and testing, rotor thickness, which we talked about, check against manufacturer specifications, Pad thickness, minimum 3 to 4 mil, it says there. Drum diameter, if we've got brake drums, we need to measure the inside diameter of that. If it's too large, then it needs to be thrown out and replaced. Record all findings against manufacturer's standards. Document measurements on service report. Compare vehicle-specific tolerance ranges and note components requiring replacement. Not too far. Let's go back here. Troubleshooting common challenges. Brake pulsation. That's what I was talking about with shudder. When we've got warped rotors, it will cause brake pulsation. Excessive noise, squealing or grinding indicates worn brake pads, worn right out. Spongy brake pedal would mean that there's air in the hydraulic system, which would require bleeding. Vehicle pulling to one side when braking. So if your steering pulls one way when you're braking, there's probably a good chance that the wheel on one side of the car, the brake is not working at all. Troubleshooting, caliper issues, seized pistons, we talked about, due to moisture content in the brake fluid, causes rust and causes seizures. Rotor problems, warped rotors causing vibration, excessive run out, they would need to be machined. We check that with a dial gauge. Says there, machine or replace. Hydraulic issues, air in system requires systematic bleeding, or it could be leaking. Identifying component wear, so we have a visual inspection, excessive wear on the brake pads, how that wear is occurring, whether it's one pad's wearing more than the other, if it's wearing on an angle. If it's wearing on an angle, we could have seized slides. If the inner pad is worn more than the outer pad, we've probably got 2 seized slides. If the outer pad's wearing more than the inner pad, we've probably got seized pistons. And obviously check the rotor for signs of scoring, heat. So, our summary and best practices. Always select the right tool. Always follow workplace safety procedures. Always document everything. Preventative maintenance. Always keep a record of everything we're doing. Okay. So that way everyone's got a record of it and we know the history. So that about concludes our lesson on selecting, identifying the right tools. So I've got a quick little pop quiz for you. If you just want to have a browse through there. And after that, there is a feedback form. Thank you, Tommy.